be, do I continue drilling, do I stop drilling, do I change where I drill next, or do I move on to a different... Maybe in a blast hole sense, that is how do I then define the way that I'm going to move the rock after it's blasted.
It's just shake the mouse there.
So it doesn't matter where you
just
are,
shake the mouse.
process of drilling is cyclical. In exploration, that cycle at the moment probably anything from 6 weeks to potentially 6 months to move around, maybe a year. In the blast hole environment, say up in the Pilbara, that cycle might take, say, 72 hours to move around. I mean, in both cases, though, it's too long. And the problem our industry faces right now is that cycle is just taking too long to move around to really get the productivity gains we need to see in our operations. I guess the other thing as an industry we face then is that if we start to then try and address the problem of moving around that cycle quicker, that is the provision of technology to generate data a lot more rapidly, then we're dealing with data streams. But I think one of the really important things for a lot of what we do, and I think potentially geophysics is the one exception to this, but for a lot of what we do, especially around the drill hole, we're not actually dealing with big data in most cases. We hear the phrase big data being bandied around a lot, but in geoscience we're not really dealing with big data. But what we're dealing with, it's not big data, but it's complex data. It's lots of noise, and there's lots of missing data. And so, one of the real challenges we face is that we are trying to deal with incomplete sampling and incomplete data sets. So it's not big, but it's quite a different challenge. And I think that's been an interesting learning for people trying to access the kind of the analytics space in this area, is that if you just go and talk to the traditional data mining community, they really grapple with the complexity of the noise and the incompleteness of the data sets that we deal with. Downhole geochemistry would be a good example. So we're dealing with the missing data, and often it's the little man in the jigsaw puzzle there. I mean, often the missing piece is the really critical one, and you stand there trying to understand how you're going to resolve that problem. And we use proxies and that kind of stuff a lot. And that picture in the top left, it's actually a drill hole. You can see the little orange line there. There's a drill hole in a seismic reflection profile. That was MSDP-01. It was a drill hole drilled as part of the South Australian government's regional drilling programme. And that particular drill hole, we have a fantastic downhole geochemical data set and downhole mineralogical data set from the lab at Rig. We deployed that unit to that hole. So we had that data in near real time. So beautiful data set. But you can see there that you've got incredibly dense downhole data of multi-component data, but it's a single, very thin line in an otherwise complex bit of geology. And I think that's one of the challenges we're grappling with, is how to then fuse that very, very intense downhole data with the kind of data that senses the volume of rock around it, and then being able to make decisions around that. I mean, one of the things, and again, this is probably a slide I've shown a couple of times, and one of the great learnings as well is that we talk about industry 1, 2, 3 and 4. Industry 3 was obviously the advent of computing. Industry 4 is all about connectivity and analytics. This is driven by manufacturing in a large part, that driving the processes here. I think it's worth remembering as well that we think a little bit about Industry 4 not having arrived within our industry, but it has. And we're increasingly seeing that we have access to tools and technologies around the drill site now that provide data in near real time, and that's been a big driver for our company. And so you can see on the left there's a beautiful picture of Adrian Fabrice from the Geological Survey doing his normal kind of geology bit, but he's looking at core while having access to the full geochemical analysis of that core, because we're providing that data from laboratories. So you can see that plot there. So the key there is that as a geologist, he's still looking at the core and logging and making decisions, but he is supported in doing that by a set of downhole geochemical plots. So we can do that now in near real time. The pictures on the right there are actually a couple of snapshots from deploying a gamma a Gamma Pro to Aircore. So this is our Easy Gamma product. So this is a driller deployable natural gamma tool. This is a really good place to start. It's quite an easy technology. But a driller is now deploying that. So the data is then consumed into the GetAct device there and then piped up to our cloud-based environment. So the geologist on the ground can use that gamma signal now to say something about the way they log the chips. And the person back in Perth or Vancouver or wherever can then start to consume that data in near real time and then start to make geological models. So that's all here and now. So we are actually in that phase of getting our industry to respond to the Industry 4 agenda. But I guess one of the big challenges we face is that we potentially run into a problem around the fact that we're now going to deliver lots of data to our geologists, but we're requiring our geologists to make decisions, so we need to turn the data into information. I mean, the more kind of disparate data sets we give that person, they are going to just become overwhelmed and it won't really help the agenda. So I guess the geo data analytics or that kind of geological based data analytics piece is actually then about turning multiple data streams that are coming in from the field in near real time into information products to really support that person to make a geological decision or to make a decision about what they're going to do next in their exploration program. So I think that's the kind of challenge our community faces in the kind of the data coming from drill rigs. And one of the challenges I guess we also face is that the data coming from the drill rig, if you look at all the gamuts of technology out there, is also coming at different rates. So if we look at something like lab at rig for diamond drilling, you're delivering 1 metre composite geochemical data, probably a couple of hours after the interval's been drilled. If you're looking at something like monitoring while drilling data or measuring while drilling data coming from a drill rig, that could be anything from microsecond resolution data if you're looking at drilling performance, or aggregated up to data sets coming in every 30 seconds or something. So there's a lot of different speeds of data and quantities of data coming in off the drill rig that we need to then fuse. So data fusion is a really key parameter here, but then it needs to be turned into information that actually supports the decisions that need to be made, not a set of new data sets. I use this term a bit. I mean, I think as we progress as an industry, data, it actually allows us to behave very differently in the way that we run exploration projects. So if we can now have near real-time geochemical data, for instance, at the site of drilling, it means we can make decisions not only about where we are in the hole, what the hole is doing that we're currently drilling, but more importantly, I think that the really important thing is that we can make a decision about whether we walk away much earlier than we've ever been able to before. So if you've got a fixed budget you're putting into a tenement, wouldn't it be nice to be able to walk away from that with hole number 1 instead of waiting to drill the 6 diamond drill holes or the 4 diamond drill holes and then realise 6 months later that actually we didn't have anything in the system. So I think what we'll see is a change in the way that we work to more rapid testing, rapid iterations in our exploration. We want to fail fast, actually. That's a really key thing about the Agile approach. Agile, of course, came out of Agile product development and Agile manufacturing. And there's embracing failure will be one of the things that we do have to change the way that we work as well. So being more comfortable about taking all this information and actually making the decision to walk away early. So I think the process around artificial intelligence will be how do we take all of those multiple data streams and present information to the people that make decisions to really facilitate us as an industry to work in a more agile way around our exploration projects. I guess a couple of examples. So this is stuff I've been playing with. I know Steve Fraser, I think you're there. You probably talked about self-organising maps earlier. So just as an example of the kind of thing that I've been playing around with just lately, it's the kind of thing I do in the evenings because I can't sleep well. But this is just an example of sort of an automated mapping, if you like. So here's here's a radiometrics survey over Kintyre deposit. So this is a public data set. It's made publicly available. So you can see there's an RGB image like you'd normally see for radiometrics. I think it's a scaled image. And you can see there that obviously the radiometric response per pixel there is a response of the regolith and the lithology underlying that pixel as the survey was flown over the top. So this is pulling the data in its raw sense into iogas here. But a real question was, how can you rapidly turn that into something that's meaningful? So I was using that data set there to play around with the self-organising maps. So we've included SOMs into iogas. And so they're just taking the three components, potassium, uranium, thorium. There's a very big data set in the first instance, so we can subsample that. So I took 10% subsample, ran that through the self-organising map. So we're really looking at how does that data self-organise itself into classifications, generate the SOM, and then go back, apply that SOM on the full data set to generate an image, which is a sort of a classification image of that radiometrics data set. And that process there in iogas with the public data set took a matter of 10 minutes or so to do. So in 10 minutes, we go from a raw data set to a classification of that radiometrics data, which is clearly an indicator of the kind of regolith, lithology, soil profile in the pixel under that survey. So in 10 minutes, we've gone from a raw data to something that the geologist can look at as a map, a type of map. But I think the really key thing here is that it's a SOM attributed regolith map, if you like. But the key thing here is that there's a hypothesis test to be done, so that you can do this, but you're not just going to rely on this because you don't entirely know what all those different classifications really mean. And so then you would go back into the field and then just try and attribute what those different classifications mean with field work. Okay, so that was a process that took 10 minutes to turn a radiometric data set into something that looks more like a map. And that's the kind of thing that then supports the geologist to make a decision. So it's a data-driven classification, turning it into something that really supports that person to go and do field work properly. If we think about some of the drilling processes and where we're starting to see these analytics pieces being used, this is just a slide we used to talk about next generation Aircore exploration. So this is, I touched on this a little bit earlier. So this is deploying our Easy Gamma tool on an Aircore rig in an exploration project. So things are moving pretty quickly. But as I said, the geologist in the field then has access to that natural gamma signal. They can immediately make a decision about what those 2 or 4 metre aggregated piles of chips really represent in the profile, rather than trying to understand. So that it helps in their geological logging and mapping. We can see it, or you can see my mouse, but you can see where those key interfaces are there in the regolith profile, which is the top half, and then as we get into the fresh rock, which is that key interface at 65. So in the geological mapping sense, you immediately know what the interfaces are. You can start to build that picture as you go. The other thing is that in this particular program, they're then taking samples from those chips with portable XRF to measure the chemistry. One of the key things they wanted to know of was where are the lag samples, for instance. Where are those key interfaces? Where can I sample those key interfaces to pick up heavy minerals? So immediately with the presentation of a natural gamma result collected by the driller, that geologist again knows where to go and get those interface samples from, rather than trying to make decisions on looking at the colours of chips. So this is just a really manual sense of how you can start to use that data, but I'll show you how we can start to bring the kind of the analytics piece into this as well. Here's an example again of gamma being run down. This is actually the deep diamond drill hole that was run underneath the super pit in Kalgoorlie, so the KTGM deep hole. So I think this was about a 3,100 metre hole, ran straight underneath the guts of the super pit. I think one of the deepest holes drilled in Australia. It was the claim to fame. And so we had the Easy Gamma deployed on there, and so and they also then logged the core with the high logger. So you can see a set of data sets there. So on the left is the kind of coloured trace is the gamma signal. But what we've gone and superimposed on that is a thing called a wavelet tessellation. So this is a method that was developed, sort of came out of CSIRO as part of DET CRC. This is about taking a wavelet transform or a wavelet process of that gamma signal and then generating a tessellation. And really what a tessellation does is it gives you domains or areas of fine scale information on the left and coarse scale domaining on the right. And you can see, if you look at that gamma trace, you can see how, if you look on the right, you're a clumper, so I want to know my coarse scale breaks. On the left, as I move further and further to the left, I'm seeing the finer and finer scale detail. That's a real example of the fact that while you can give a geologist the wiggly line, they don't really like it, because they don't really know what the wiggly line means. But if you start to then apply something like a wavelet tessellation transform to that data, you turn it into little coloured blocks. Geologists are very visual, remember. Then immediately what you've done is given that geologist just a really quick breakup of the data. So where are my key breaks, where are my key domains, what stuff sits together, what stuff breaks apart. And the key thing there is that you can have that data at the time they're first laying the core out. So it really supports their geological logging. It's almost like a quick log before you get into the detailed logging. You know where to go to look for the detail, you know where to go, what parts of the core don't have a lot of detail in, so you don't need to worry. But I think the other thing this illustrates, and we've got the high logger data there as an example of another kind of data set that can be delivered. High logger is one technology, core scan would be another that does this kind of stuff. But I think what you start to see there is that if we were able to better fuse all of those data streams and then present that to the geologist on the tablet as they're first logging the core, how that information would then support the way that they log the core and make a decision. So it's about making a decision while a drill rig's still turning. It's also about making a decision or supporting a decision while a geologist is logging. And I guess we're coming back to the Aircore example. Here's another example here from a porphyry system, again with the Easy Gamma trace there in red. But here we've got some pre-existing geochemistry. So this was run on a test borehole and a wavelet tessellation there in the middle. And one of the other things I think we'll start to see is that we can start to use something like gamma data to then help us decide the intervals at which we take our multi-element data or we start to collect other data sets down the track. So if you look at this, you start to see texture in the gamma data that tells you about the texture of the rocks. So that unit above is actually just a volcanic unit in the geological log. The unit below is the porphyry, so the one with the big gamma kick. But what you're starting to see there is texture within the volcanics, for instance, that you can see in the gamma data. So in many respects, we didn't need to take all of that geochemical data, right? We could have used the gamma data with the wavelet tessellation to really make a decision about how much detailed geochemistry testing or geomet testing, if that's where we're going, how much of that we need to do and over what interval, and how we want to start to break our ore body apart. So feeding that kind of analysis from the very first drill hole, the very first data you collect from the drill hole, that data eventually ends up in the 3D model, and that's a really critical part here. And we need to then take the multiple data streams and turn them into information products to aggregate them into the 3D model. So here's just a final example of where we played around with this aspect of this kind of machine learning. This is again using SOMs. I'm a real fan of using self-organizing maps for this. It's a very data-driven approach. So again, this is lava rig data. I'm just plotting one component there, titanium. But we collect 35 elements with portable XRF, very good quality data, very consistent data. So there are 4 drill holes from a single tenement. Not necessarily in order, but what I've done there, that coloured bar on the left, is actually a self-organising map classification based on putting all of the lithogeochemical elements into the SOM. So we've done a centred log ratio transform, we've taken that data, we've put the lithogeochemical elements in, because what we're saying is, I want the SOM to tell us about what it believes the self-similarity rock type is across those 4 drill holes. So immediately you can see as a geologist that there is transitions in the colours there in MSDP01 on the left-hand side that are reflected in MSDP03. And so what we can do is generate a SOM with drilled hole number 1 and with drilled hole number 2. We go and generate the SOM and we apply that back to the data coming off hole number 3 and hole number 4. And immediately we can start to build that geological model quite quickly. It also then tells us where we have new stuff that appears and that kind of stuff. So just supporting the geologist to make those decisions about where I am in the chemostratigraphy and to do that very rapidly. One of the key things in the exploration space, I think, one of the key impacts here will not be that we won't drill hole number 1 or hole number 2. It will be that if we can save the drilling of hole number 4 because we know what's going on and we've answered our model, then that's the cost saving we need to pay for the technology we need to generate the data. There's the value proposition. So that's just, again, an example of something that can be done really rapidly. We're running that in IMDEX in this instance on the data as it comes in from the field. So the geologist is letting the artificial intelligence there present information to them where it takes multi-dimensional data and presents it as a single information product to help them make a decision. Now, they're not going to just sit there and take that for granted. They are then going to use that in the logging process. But at least we can make a decision about what's going on at the time rather than trying to modify our model 6 months or 12 months down the track. We can make a decision about whether to carry on drilling or move on. So, I guess I've given you a snapshot there for what we're doing now, really. I mean, we've got the tools and techniques to start to bring this together. We are increasingly providing tools and technologies on the drill rig to provide this data in real time or near real time. I think one of the challenges now is actually about bringing that all together into workflows within our industry. There's actually a really important change management piece in how we approach this as an industry. We are changing the way that people behave, and so there's a picture there on the left that Ken would have seen, certainly some of you would have seen. It's, what does it mean to be able to make real-time decisions? It's the question of where do I drill hole number 2 or 3, or probably more importantly, can I get away with not drilling hole number 3, save that money? And there's a bunch of processes that need to change around that to really make this viable. There are regulatory processes, there are internal business processes in our companies that are now going to have to change to reflect our ability to make decisions much quicker. People and skills is really important. I think that our universities need to sit up and take notice of the kind of technologies we're putting in the hands of geoscientists now around drill rigs, putting in the hands of drillers even, and we need to address that as an industry, as a community, around our universities really provisioning the kind of technology skills we need and the kind of numeric skills we're going to need people to have as they start to grapple with these information products. There's also a piece around shareholder value. I mean, if you can take a same budget and test 4 targets because you've been able to walk away from targets 1, 2 and 3, that's going to increase our probability of success from where it sits now, which is probably languishing around 0.25% probability of success of discovery. It's going to at least increase that if we can test more targets with the same budget. So there is an impact there in near real-time information and the analytics into shareholder value. So I guess the little cartoon I put on the right-hand side there is, I believe that the challenge we face is then how to build artificial intelligence, the cogs there of the person's brain around taking not only the data streams into information products, it has to be the right information product to support the geologist to be a geologist. So we need to support the geologist to be a geoscientist to make decisions. So we need to turn those things into information products to do that. And we need the workflows in place to then start to do that in a way that the data is flowing between systems and the real-time decisions can be flowed through to actually actionable information, not just this is a nice outcome that we got a few months later. So just a quick snapshot, I guess, of where I see things going. Things are moving very quickly here, and where we're increasingly going to need that analytics piece in the puzzle to grapple with the multiple data streams that are now starting to appear in near real time in our drilling process, and how also then it's about our ability to deal with that in the workflow. So we need the data infrastructure and we need those pieces in place. So I think I'll leave it there, Ken, and just really sort of setting people a bit of a challenge to think about what this means.
All right, thanks, James. If we've got some questions, you're comfortable fielding those?
Yeah, totally.
All right. Anybody got some questions for James? Well, one of the, I'll make a comment, and it's sort of based on the meeting we had last year, the first red blue, that and James has actually written a piece on some of this that appears in the SEG newsletter. He and a colleague put that in two issues ago. But
yeah, it was April last year.
Right, but I mean, as David was telling us, David from IBM sitting here, you know, we have these augmented decision-making processes that empower the person who's sort of at the coalface. But there's consequences as a result of that it flows down through all of the other interactions that person has. And what we were discussing was, well, what if we get this real-time information coming off the drill rig that a driller, or, you know, it was often that the drill rig is the most junior geologist, they are now empowered with information that formerly they never had access to, because they have to make decisions on that basis. They are therefore, you can say, how do they inform their superiors? How do they inform the management? Robbie Rowe commented about that they had a discussion with the stock exchange about this sort of paradigm, and basically the people at stock exchange says, we don't have a clue to handle this. Okay, if you start generating, I've hit an ore body last night at 2 o'clock in the morning, and by the way, we're drilling it off now over the next 48 hours. Management is, a lot of our people we deal with are not prepared for that sort of cycle time. Just not prepared. So it's not going to stop with the person who is the augmented person. The train is going to bump into all these other cars very, very quickly. So the sociological aspects that as I mentioned at the beginning, I mean, the technology part of it is an inevitable flow of the river, but we have to learn how to change to adapt to that. Things that we did before aren't going to work, or they're not going to work very well. And we can see this often even in the military, where soldiers in the front line now are getting information that the Pentagon is totally flummoxed, in my case, totally flummoxed how to deal with it. A lot of backbiting, you know, why did you walk into this trap in Nigeria and the rest of it? Send us more information. It's often not possible. The decision makers are all asleep at the time this is all happening. So we may be having to augment the augmenters in some other additional way that allows them to, you know, have a means to communicate information to the rest, all the other connections that these people would have access to.
Or have augmented agents to manage that, if you understand what I mean, rather than having reliance on the human interface. But it's an interesting proposition, even the notion when you're getting resistivity and the sort of MWD that James is referring to, and the clarity of information, how that's passed to now real-time mine planning tools. I mean, MineRP is a good example of a company that's now turning out geological and ore body models in real time, picking up MWD that now can feed into order books in the mine, which is having a dramatic effect on the market side of things, which is what you were suggesting.
Right.
And it is the cascading nature of the information, like I said, the river just keeps flowing. So it's now time to start to think how we start to assemble behind it, I think, because I mean, and how to maximise the power of what we have at hand technically to enable us to actually feature, to amplify that value. And what do we have to do? And that's a reorganisation of the nature of work. And I mean, I think it's interesting, really. You know, it's exciting, to be frank. The opportunity, I think, is great. It's also a little bit terrifying.
Well, I'm probably dating myself, but how many in the room would have ever heard of Marshall McLuhan?
Yeah.
The Canadian futurologist?
Yeah.
About 40 years ago. I mean, he said the future's in the rearview mirror, and it's going to come out as being, I think he can still hear us. There he is. But, I mean, that's the sort of character that we probably we're needing more now, because it's not the technologists, it's not the bright people at IBM or Reflex. Those people will do the tasks, but they're not really responsible for the overall societal changes this is going to have when these things are implemented for us. So
it's interesting though, I mean, the policies that are being struck, for example, our CEO sits on policy boards in the States that are really examining, you have your Googles, you have your IBMs, you have your Microsofts, players in the AI space who are sitting on these boards to understand the more profound implications of the impact, and ensuring that policies are starting to be understood to safeguard against certain characteristics that we don't even know necessarily. So there are some protectionary boards, but I mean, this is at a very, very high level, let alone at the cold face. So
yeah,
it's an interesting.
Well, I mean, you mentioned the medical industry. This is one where I think probably some of these approaches are going to be being able to do diagnostic tests that are going to be far more specific. You got your hand up, EJ?
Yes, actually, a couple of years ago, I was in the major knowledge and data mining conference, and one of the plenary speaker was actually head of a data company, serious data company. I can't remember the name of it. But they were saying that, of course, they do all this AI analysis of the data within that organization, and they put it on the table for decision making by the top management. But apparently, very large percent of the time, I can't remember, probably over 90%, they will actually make a decision by gut feeling rather than evidence in the data analysis. So there was a big discussion about this actually at that conference. And from my point of view, working in this field for many years, I see that in minerals industry, it has to be a building blocks. People has to demonstrate that actually AI is making efficiency improvement or coming up with better decisions in a smaller way, and then demonstrate that that actually works, and then it builds up to the top level, more broader decisions, right? So yeah, that's my view.
Right. Well, I guess, I mean, with what James was talking about, the heart of our business is as a number of people would say, to be the drilling of target or testing of targets with drill holes, and there's fairly profound results. It's either continue on or stop based on results, and so it's hard to translate that back into a small incremental decision. It can be, if you had a 150 meter intersection of a high grade deposit came in, you can't turn the clock back. That's basically becomes your future, and so some of these, but I agree, some of the events are going to be much, much smaller, but it may be we're going to be confronted with sort of large things coming out very quickly, because that's where it's not the lab with the rig isn't the problem, it's the tube drilling is the problem, and then the problem there was the cost of drilling diamond holes. And so we've created constructs that lead us to the journey we're on now in generating information that we may be challenged as to how to cope with it. I'm not sure we can control the step change all that well, because we have big problems we want to address, but there's big consequences in terms of if it's successful in terms of what the outcome is. So it may be, it's like I sort of hear you want to let the genie out of the bottle 10% of the time, but I think the genie is going to pop out fairly quickly in some spaces. Yep. I don't know if you heard any of that. Oh, Ross.
Yeah, I think it's going to create a situation where we have bottlenecks. This rapid data and rapid decision making in the field is fantastic, but certain decisions have to be made in head office, and those are going to be the bottlenecks. I can see it. All the data going up, and the job just has to sit down again and wait for a week for the next decision, because the results were so significant. They've got to go to the board, or they've got to go to the executive committee to make the next decision. So I can see that'll be a big problem. But
EJ just told us they're going to make the decision when they get in the ground floor in the parking lot. By the time they get to their office, they're going to know, because they base this on gut feel. They don't need any of that data, right?
I think the point is that there's a bit of work underneath the bonnet to get all these things in place, mobility, All those sort of aspects need to be put in play before you get that efficiency going. Good point. I mean, it is the maturity. The maturity curve needs to be struck before those bottlenecks get, those pinch points get removed.
Right.
How do these various systems tell the difference between fact and dogma? I mean, for example, 300 or 400 years ago, would Watson have told Christopher Columbus not to set sail? Or
James, did you hear Kim's question?
Yeah, just repeat that for me.
Kim asked, how will the systems be able to tell the difference between fact and dogma?
I mean, I guess the reality is you're just presenting information still to the geoscientist. The geoscientist at the end of the day has to be a geoscientist. I guess one of the things that we will do by, if you think about something like lab rig, one of the consequences of routinely delivering multi-element geochemical data and quantitative mineralogy for every metre that you drill, just because it's part of the system, what it will do, of course, is it will open up discoveries in places we're not thinking about. So actually, as an industry, we can't walk into that only looking for a particular thing. We're going to have the data to make discoveries or to understand the systems at a much bigger scale. So a really obvious one is you're drilling for basement copper, but actually if you're sampling the cover, which we don't often do well, do you run through a sediment-hosted copper system further up in the sequence? And you wouldn't normally know that, particularly unless you could see the subtle signals maybe in something like lab rig. So I think it will open up, because we'll start getting more data streams through different parts of our system. We will have to be more open-minded about what it means for the systems we're looking at.
Okay. It gets down to the comment. Steve Fraser here, James. It gets down to the comment that I made about unsupervised and data-driven and exploratory. By using those three things, you get rid of the dogma, because the data is going to tell you what's in the data. And so that ideally, then you've got to make your decisions very rationally, not based on dogma. But certainly the data should tell you what's in the data.
The notion of dogma is decodable as well, though. I mean, you can,
exactly. It's decodable.
So it's I mean, a lot of the drivers, or a lot of the outcomes, that are being presented in AI now are very much about decoding, emotion in terms of empathy, intuition, things of these sort of intangible natures that are being actually decoded. So dogma is something that can be decoded. If truly you want to actually drive based on dogma, if that's your driver, very unlikely, but it's, it is
It could be argued that don't take any data.
Sorry?
It could be argued that why collect data?
Yeah, that's right, yeah. Look.
Yeah, you've created some interesting discussion with that, James, so yeah.
Yeah, cool. Yeah, Ken, I've actually got to dive off now. Got to get a little one to school.
Sounds okay. Thanks very much again, James.